Hi, I'm starting this channel because I've sometimes noticed at school that students may struggle with math, even when they're actually able to understand it. I think math becomes easier when it's not just abstract, but when you can see where it appears in real life. So I want to explain math using simple real-world examples. So this is my example for the first video. During a school field trip, a group of 9th grade students visits a mechanical engineering company. Inside the factory hall, they observe different machines used to manufacture metal parts. One of the engineers shows the students a metal guide ramp that feeds small components into a CNC machine. The ramp is slightly inclined so that parts can slide smoothly into the machine. The engineer explains, this metal guide is designed with a constant slope. At the beginning of the ramp, the height is 0 centimeters. After a horizontal distance of 50 centimeters, the ramp reaches a height of 10 centimeters. Engineers often describe such shapes using linear functions. Because the height increases at a constant rate along the ramp, the engineer then challenges the students to describe the ramp mathematically. Okay, so here you can see another clearer picture of our ramp. At the start, it has 0 centimeters of height, and as it reaches a distance of 50 centimeters here, the horizontal distance is 10 centimeters. So we need to find, in this triangle basically, what this linear function is, or the function of that slope. For that, we here have a coordinate system. I'll quickly put the numbers down. I'd say an appropriate distance would be 5 centimeter intervals. So we're going to start here and just go up to 50. Now we're going to go up in steps of 5. All right. And now for the height, as we're going to reach a maximum height of 10 centimeters, I'll also go up to 10 centimeters. Okay. So now the only thing that we have to do is basically graph our linear function. Starting off, we have to first see where does it start. Because it starts at, as you can see here, 0 centimeters, we're going to start from the origin of the coordinate system, which is here. Starting from there, we know that when we travel a distance of 50 centimeters, it goes up 10 centimeters. So if we look at that in our coordinate system, as we go a distance of 50 centimeters, it'll go up 10 centimeters. So our point is here. Now we can draw our linear function. Okay, now we have our graph. And now we can just read off our linear function for that graph, which represents the slope. And after, we're going to quickly test if we actually got the right linear function. So the normal form of the linear function is y equals mx plus c. Here, m represents the gradient, so how much the graph goes up over a specific distance where it's gone over, so how much up while it's traveling a distance. And c represents the y-intercept, so basically, because this is the y-axis, c shows us where it's crossing the y-axis, which is, for our example here, this point. So now we can just basically read it off. So we will write y equals, we look at the gradient, which is it travels a distance of 10, or it goes up 10 over a distance of 50. And because gradient is rise over run, so the change in y over the change in x, in our case, that will be 10 over 50, which we can simplify and turn it into 1 over 5, which is the same as 0.2. So our gradient is going to be 0.2. Now we can write the x, and for our y-intercept, we can see that it's going through the point 0, or the origin of the graph. So we will basically write a 0, but you don't have to write that 0 because adding a 0 doesn't change anything. So if the graph goes through the origin, as it does in our example, you can just leave out the 0, and then our linear function would basically be y equals 0.2x. So now that we know our linear function for this slope or the ramp, we still have to test if it's actually correct. And the way we do that is, because in our function there is, as we can see here, y and x, we can substitute either of those variables with numbers from our graph and check if we actually get the corresponding number. So let's say we choose the number on the x-axis 25. Then the number we should get on the y-axis would be 5. Because if we draw a line here towards the graph, and then a line from the 25 towards the graph, we would cross it here. So if we use 25 for x, we should get 5 for y. So let's try that. So we're going to write y equals 0.2 times, or as I like to do it in brackets, times 25. And now you can either type that into a calculator or just quickly do it in your head. But it's basically 1/5 of 25. And 1/5 means you need 5 times of that. So 5 times 5 is 25. And therefore, y equals 5. So as it turns out, we do have the correct linear function. And we can also do that the other way around. For example, if we use 5 for y, if we do 5 equals 0.2x, we now want to get x, so we would want to have 25 as our answer. Now we have to, because it's 0.2 times, there's an invisible times sign here. We have to now do it divided by 0.2. So on this side, 5 divided by 0.2 equals x. And now if we do that, we will basically get 25 equals x. So again, we proved that it's the correct linear function, and that is basically it. So now we know that, first of all, we have our linear function, and we know that this slope has a gradient of 0.2. I hope I could help you guys with this video to see how linear functions can be used in everyday life. And I'll see you guys in the next one.